Welcome students to the next lecture of ESD. In this lecture, we are going to start with chapter number 2. Chapter number 3, it is a programmable timer counter chapter. In this chapter, we are actually going to study two ICs. First is IC2240 and second is IC74926. So let us start with IC2240. This is the index. We are going to see the introduction to the IC followed by the block diagram of the IC2240. We will see the description which includes the pin description. Then we will see the operating modes and we will discuss in detail what are the different operations of the IC2240. So, this is basically related to the timing delays. So, what is a time delay? Time delay is nothing but you are like setting the alarm. So whenever you set the alarm, you are defining a predefined time. So you are going to perform a particular event after a certain amount of time. That you are calling it as time delay. Okay. So if you need to generate a time delay, how to generate it? So for that, there are various types of circuits used there. Out of that, let us see different circuits used there. So very simple circuit used to generate a time delay is use the simple RC network along with some ICs which will generate. So RC network and a comparator, and then you can get a time delay there. Next popular circuit used frequently is the IC555. This is also serving the purpose of generating the time delays for various things. In lots of circuits, you are required to generate the time delay. So for generating those time delays, IC555 is used. Along with that, today we are going to study one special IC, IC2240. So basically IC2240 is used to generate the time delays. So if you want to have a very small time delay right from microsecond to very long time delays up to few days, you can use ICs like IC555 and 2240. 2240 is used for a very large time delays. Then another use of 2240 is a generation of a square wave. It will not only generate the time delay, but periodic waveform can also be generated for our predefined frequency. So you can decide the frequency of the oscillation, and for generation of that we are using the IC2240. Now what is the IC2240? IC2240 is programmable timer counter IC. So you can program it, means you can decide the time delay or you can decide the frequency there. It can generate very accurate time delays right from microseconds to days. The programmable delays are varying from 1 RC, where R and C are the components connected to the IC, to 255 RC. Now, IC2240 operates in two modes. First mode is monostable mode. In monostable mode, it is actually generating the time delays. So here, only one pulse is generated. In the second mode used there is the astable mode. In the astable mode, it is generating the continuous waveform. So this is a continuous waveform which is generated in the astable mode. So IC2240 can be used to generate time delays. When it is used to generate the time delays, it is working in monostable mode, and whenever it is generating the continuous waveform, it is used in astable mode. Now let us see the pin diagram there. Internal details we will see afterwards, but just for your information, this is a time based circuit. Okay, so this time-based circuit is actually going to generate a waveform. It is given to different binary counters. Okay, and these binary counters are going to generate different outputs. So if you see these outputs, there are total 8 outputs are there. Which are the 8 outputs? O0, O1, O2, O4, O8, O16, O32, O64 and O128. Total 8 outputs are there. So 8 different delays can be generated at a time, and 8 different waveforms also can be generated at a time by this 2240 timer counter IC. So it is having two inputs. One is resistor capacitor in. Here you are going to connect your resistor as well as capacitor. Okay, then it is having another pins are regulator out, time base out, resistor capacitor in, modulator in, trigger in and reset. I repeat it, regulator out, time base out, resistor capacitor in, modulation in, trigger in and reset. These are different control and different various pins available with 2240. We will see these pins one by one in the coming slides. So the first part is counter inputs. In the previous slide, we have seen that there are different counter inputs O0 to O128. So what are these? These are the counter outputs. There are 8 binary counter outputs. Okay. So what are these binary outputs? O0 to O128. Okay. What these outputs are giving you? These outputs change the state in accordance with the timing diagram. So how they are changing, that is given here. Okay. So if you see O0, it is generating one waveform. Okay, so let us say if the frequency of this waveform is f1. Okay, and then if you see the output of O2, that is second output of IC2240, it is generating the waveform which is exactly half of f1, f1 divided by 2. Okay, this is f1 divided by 2, that is O2. If you see O4, output 4, it is its time period is double of the previous. It means its frequency is half of the previous one. That is f1 by 2 divided by 2 or f1 divided by 4. Okay. Next is f1 divided by 8 and therefore you can get the name there. Every time the time period is multiplied by 2 whereas the frequency is divided by 2. Means the previous frequency is divided by 2 in the next output. So such there are 8 different binary counter outputs are available with IC2240. Okay, but to generate these outputs, you have to give the trigger input. Now, what is a trigger input? We will see afterwards. Then, how you can use these outputs? So, this is very important. Counter outputs can be used individually. Means you can use either O2, O0, O32 for your purpose or you can connect them together in a wired or configuration. We'll see afterwards what will happen if I combine O0 and O2 or if I combine O0 and O8. Like that, I can have any combination of the two outputs. Now, how to use these outputs, we will see afterwards for generating different types of the waveforms. Next two pins, reset input and trigger input. Now, what is a trigger input? What is a reset input? Once triggered, the circuit is immune from additional trigger inputs until the timing cycle is completed. So once you trigger the IC, it will start the timing cycle, but it will not stop in middle of that if you try to give the trigger input again. Now, if you want to interrupt that timing cycle, you have to reset. So what is a reset thing? Reset will interrupt any operation anywhere, okay, and it will restart it. And whereas what is a trigger? Trigger will be applied only once. It will be activated. Application of a positive trigger going in trigger pulse to the trigger pin initiates the timing cycle. We have seen the timing cycle in the previous diagram. Here, this is the timing cycle. So what happens? Here you are giving one trigger input. So when you give the trigger input, this is first waveform is generated, then the second waveform, then the third, then the fourth, then the fifth, then the sixth, seventh, 128. And after 128 complete cycle is completed, then only it will stop. Okay. So until that, it will not be taking another trigger input. So remember, trigger input activates the time-based oscillator present inside it. It enables the counter section and it sets the counter outputs low. So these three things are done by the trigger input. Whenever the trigger input is given to IC2240, it is going to initiate the timing cycle. How it will initiate the timing cycle? By activating time-based oscillator, by enabling the counter section, and by setting the counter outputs low. Here in the diagram, the trigger input is given. So this is the trigger input. The first one is the trigger input. Here it is given. Okay. And then you are having the time-based output is generated. So once the trigger input is given, these time-based pulses are generated. One, this is first, this is second, then third, then fourth, like that. And then repetitively O2, O0 output is sorry, this is O0, then this is O2, then this is O4, then this is O8, next is O16, and then it is continued up to O128. Like that, the outputs will be generated whenever you are giving the trigger signal. Next, let us go through the remaining terminals one by one. RC terminal. The time-based period T is determined by the external RC network connected to this RC terminal, that is pin number 13. So at pin number 13, we will connect both resistor and capacitor. When the time base is triggered, the waveform is generated at this pin is an exponential ramp. Means it's a charging discharging of the capacitor which is connected. Then the next one is the time base output. The time base output is high. Normally it is high whenever it is in the reset state. And when you give the trigger input, it is going to generate a negative going pulse train. We will see once again in the previous slide. So this is the time base output. It is going to generate the negative pulses. It will not generate the square wave, whereas a time base output will generate the negative pulses. Okay, with a period of t is equal to RC. And what is the regulator output? Regulator output is the supply voltage. The regulator output is used internally to power the binary counter and the control logic. Like V reference in 3524, here we are having the V regulator output. It is also used in cascading. Whenever you are using the cascading, it will give the supply to the next IC. So this is about the pin description of the 2240. So let us have one question there. The question is, uh, this pin of which pin of IC2240 is used to internally power the binary counter and the control logic? This terminal can also be used as a supply to additional LM2240 circuits when several timer circuits are cascaded. So the options are A. Trigger, B. V register, 3. V regulator, C. R, and D. Mod. So tell me what is the correct option there. You can put your option in the chat window. You can tell me which is the correct option there, which pin is used to give the power supply to the binary counter present in IC2240. Okay, so I will give you the answer. Here is the answer. The answer is B. B is nothing but V regulator. So this is actually the internal regulated power supply which is used to give the supply to the binary counter present inside the 2240, and if you are doing the cascading of same ICs, there also it will work as a voltage source. Okay, next. This is the block diagram of IC2240. So we have seen the different pins there. Trigger input is there. Reset input is there. Then RC terminal is there. Register out, that is V register is there. VREG. Time base output is there where negative pulses are generated. Q0 output is there, or actually it is O0, O2, like that you are having the different outputs. Pin number 1 to 8 are different output pins. So what are the different waveforms? How the waveforms are related here, that is given. Here you are giving the one trigger pulse. When you give this trigger pulse, it is going to generate a time-based signal, that is negative pulses. These negative pulses are shown here. So this is the time-based signal. Then the first output, which is generating one frequency F1. Then this is F1 divided by 2, then F1 divided by 4, and finally this is F1 divided by 128. A very long waveform is generated there. How many such outputs are there? 8 outputs are there. And 8 different outputs are generated at the output of the IC2240. Okay, so this consisting of actually this binary. Actually, you can say that these are the flip-flops are present there. Binary counter means. So the output of the first flip-flop is given as the input to the second one. Then the output of the second is given to the input of third, and so on. And here you are having the RC network which is going to the time-based oscillator, and the time-based oscillator will generate the negative pulses. And this whole thing is controlled by trigger and reset input. Trigger input will start the timing cycle, and reset input will interrupt the timing cycle. Without reset, you cannot reapply the trigger. So if you want to re-trigger the circuit, you have to give the reset. Okay. So first you have to reset the thing, then you have to trigger it. It will start the timing cycle. And this voltage regulator is giving you one constant power supply, okay, which is used in case of the cascading, as well as it is used in different circuits. Then the operating modes of IC2240. IC2240 works in two operating modes. First one is monostable operation. The second one is a stable operation. So what is a monostable operation? Here we are having the monostable operation. Monostable operation means here actually the output of the monostable operation is given. We are generating a one pulse. Okay, means we are generating a time delay. Now, how it works in the time delay or how it works in the monostable operation? It can generate microsecond delay also, and it can generate the delay up to 5 days also. Means one you can trigger anything after 5 days also using IC2240. Such a long delay can be generated by one single IC. Then you can also extend those delays. You can increase it up to 3 years also by cascading two timers. Means if you connect the two timers, then it can go up to 3 years also. Means that long delay we can generate using the timer IC 2240. What this timer consisting of? It consisting of time-based oscillator which will generate the waveform. 8-bit counter means it will generate 8 different outputs, and it is having a control flip-flop which is driven by trigger and reset. Then it is also having the resistor capacitor network, RC network, which sets the oscillator frequency. We can program it. Therefore, it is called as programmable timer counter. Then how much delay we can get there? We can get the delay times from 1 RC to 255 RC. 1 RC time constant to 255 RC time constant. Now, how we can get the 1 RC and 255 RC time constant? We are going to study it in detail when we are going to study monostable operation mode of IC 2240. Now, okay, question time. So, the question is monostable mode of IC 2240 works in dash operation. First option is discontinuous mode, that is non-repetitive waveform. So is it generating the waveform in the monostable mode? B. Continuous mode, that is repetitive waveform. C. Pulse mode, waveform generated only once. And D. None of the mentioned. Okay, means is it generating the repetitive waveform? Is it generating the non-repetitive waveform? Or it is generating the waveform only once? Think over it for 5 minutes or 2 minutes, and then I will give you the answer, or you can write your answer in the chat window. The answer is C, pulse mode. The waveform will be generated only once. Then the next mode of the operation is astable. Okay, what is a stable mode? It is generating the continuous square wave. Okay, now whenever you are talking about the square wave, you have to decide the frequency of the waveform. So for that you need the base frequency. So here a single RC network is used to set the base frequency. Okay, then it is generating 8 outputs. Okay, the frequencies of the square waves at the 8 outputs are each at a different factors of 2 from the base frequency. So you are actually dividing the base frequency by 2 every time for next output. So 8 different outputs are there, and for every next output you are having the frequency half. Time is doubled and frequency is half. If two or more of the outputs are sorted together, various pulse patterns can be generated. Now this is interesting. How to generate the pulse patterns. How you can generate a different pulse pattern. This is more interesting. So this is the circuit diagram. How you can connect the IC LM2240 for various configurations. So now I hope you are familiar with all the pins. What is there inside LM2240 or IC2240, and we will see this structure and then we will stop here. Okay. So this is RC pin where we are connecting. R is connected to the VCC and C is, so this is the R, this is connected to the VCC and C is connected to the ground. So this is RC terminal. Trigger input, here we are giving the pulse which will initiate the sequence, timing sequence. Reset, you have to use this whenever you want to restart the sequence, whenever you want to re-trigger the circuit, then you have to do that. In between the whenever the delay is going on, and then at that time if you want to reset it, you have stop it and you have to once again start it, you have to give the reset signal. V regulator is nothing but the supply voltage, and here are the outputs. Time base output, this is the first one, O0, O2, O4, O8, O16, O32, O64 and O128. The pin numbers are 1, 2, 3, 4, 5, 6, 7, 8. And pin number 14 is TV0, time base 0. So if you see here, the time period of every waveform is written here. T, 2T, 4T, 8T, 16T, 32T, 164T and 128T. Okay. And you are getting the time period as 1T to 255T. Remember 128T, when I am saying T on period is 128 and T off period is 128. So overall time period how much I am getting? 255T. Okay. So here 8 switches are shown here and 8 switches are given to the output. So if I connect one switch, then I am getting that time period at the output. So if I connect switch for pin number 8, I am getting 128T on and 127T off. So it will be total 255T. Okay. And then this T0. So T0 can be 1T to 255T. We can have any combination there. T, 1T, 2T, 3T, 4T, 5T up to 255T. Anytime this T0 can have any time period connected there. Okay, and how you can connect it? By using this switch. Okay, by reset it. Once you reset it, then you can apply the trigger. As soon as you apply the trigger, what will happen? It will generate the time delay. And which time delay you want? According to your design, you have to connect the switch. Then you will get the output there. Okay. Modulation input we are not going to study now. It is out of scope, so don't bother about it. And here for this particular combination, you can see that time base is connected to V regulator. Okay, because it is requiring the pull up. So this resistor is actually working here as pull up resistor. So I hope you have understood this, and we will stop here. In the next lecture, we will more explore a stable mode and monostable mode of IC2240. Thank you, students.